Okay, we're going to do some notes on acid-base neutralization reactions. And we're going to start with just a quick little review. Remember that we have acids which have pH less than 7. If you don't know that symbol right there, that's less than, you should type out the words less than, okay? Bases have pH greater than, 7. And neutral is pH equals 7. Okay, so we need to remember those things. Just keep them in your brain so that we can work on this. So here's what a neutralization reaction is. Neutralization reaction. Definition. This is when an acid and a base react to create neutral products. When an acid and a base react to create neutral products. So acids and bases are on the opposite side of neutral. So when you add them together, they react and they are going to create neutral products. Okay. Acids starting with H and bases ending with OH react to make water and a type of salt. Okay, so we always think of salt as just whatever we sprinkle on our food, but there are a lot of ionic compounds that are considered salt. They would all taste salty to us, slightly different, and some of them would be toxic to us, but they would all have very similar properties beyond that. Okay, those are neutral compounds, and they are they're ionic, and they're made out of the anion from the acid and the cation from the base. Okay. In parentheses here, I'm going to write the charges of the acid anion and the base cation must balance when writing the formula of the salt. Whoops. Of the salt. Okay. These reactions are double replacement reactions. So we learned all of the types of reactions in our last unit. Acid-base reactions are double replacement reactions. They're just a special type of double replacement reaction. Okay. Remember, the definition of that is we have two compounds trade partners to make two new compounds. Okay, we are going to do some examples at the end, but just bear with me here. When you mix an acid with a base, the pH moves towards neutral. Okay, we've already talked about that. You've got opposite ends of the neutral of the pH spectrum. When you mix them together, we're going to get closer to neutral. It's going to move towards neutral. Okay, but it only becomes neutral. It only becomes neutral if all of the acid molecules react with all of the base molecules. Okay, so if you have exactly the same number of acid molecules as you have base, they are going to make all 100% neutral substances when they react. But if you have more base molecules than acid, the ending pH is going to be basic because you have leftover base after the reaction. Or the other way around, if you have leftover acid molecules, the pH is going to be acidic. Okay. If the concentration of the acid is greater than that of the base, then the end pH will be acidic. Okay, acid molecules will be left over after the reaction. So again, if you have more acid molecules, a higher concentration of acid molecules, there's going to be more acid left over afterwards, and the ending pH will be acidic. We'll just write the same thing, but with base being more concentrated. If the concentration of the base is greater than that of the acid, then the end pH will be basic. Okay, base molecules will be left over after the reaction. There's a lot of pressure to type when you're in front of a camera. Okay, base molecules. All right. If all acid molecules and all base molecules are gone, okay, reacted with each other, what's left is water and salt, both neutral. So pH equals 7. Okay, so if you have exactly the same number of acid and base molecules, again, they all react, they make water, they make salt, both of those things are neutral, so your pH at the end would be exactly 7. Okay, there are going to be some examples. So what I want you to do is copy these examples. NaOH plus HCl, this is an L, okay? And I'm going to put a little arrow in there. So this is our acid this time, HCl. This is our base, NaOH. Okay. You're going to watch a separate video to, actually, hang on a second. That is the wrong equation. So I apologize if you've already written it, but we're going to write HBr plus KOH. Okay. That's our first example. You're going to watch another video that's going to show you how you put these together and you create the products on the other side of the arrow. Second example, Ca parentheses OH parentheses 2 plus HCl. Put my little arrow in there. Whoops. Don't know what that is. Meant to copy the arrow. All right. That's our second reaction. And then a third example is HI, so that one's an I, plus Al parentheses OH parentheses 3. And we're going to do that one as well. So I'm going to just change the fonts on these because it's hard to tell our L's from our I's. I don't know if that's much better, but there we go. Those 3 chemical reactions, you're going to watch another video and you're going to figure out how to write the other side of that reaction. And you're going to have to be able to do that when we get to our test as well. So that is not the end of the notes, but that is the end of part 1 of the notes. So thanks for watching, and let me know if you have any questions. Reach out, please reach out, and we will see you in class.